Hi, my name is Ihome Renini, and I'm here to present my APA. So this is my public health applied practice experience in City of Tacoma Wastewater Central Treatment Plant, located at Central Treatment Plant 2201 Portland Avenue, Tacoma, Washington. My supervisor's name is Scott Long, and the role I played was I monitored wastewater biology in an activated sludge process and the use of microorganisms to remove toxins in the wastewater. The first question I have is, what is wastewater and why treat it? We consider wastewater treatment as a water use because it is so interconnected with the other uses of water. Much of the water used by homes, industries, and businesses must be treated before it's released back to the environment. If the term wastewater treatment is confusing to you, you might think of it as sewage treatment. Nature has an amazing ability to cope with small amount of water waste and pollution, but it would be overwhelmed if we didn't treat the millions of gallons of wastewater and sewage produced every day before releasing it back to the environment. Treatment plants reduce pollutants in wastewater to a level nature can handle. So wastewater also includes storm runoff, although some people assume that the rain that runs down the street during a storm is fairly clean. It isn't. Harmful substances that washes off roads, parking lots, and rooftops can harm our river and lakes. Why treat wastewater? It is a matter of caring for our environment and for our own health. There are lots of good reasons why keeping our water clean is an important priority, like the fisheries. Clean water is critical to plants, animals that live in the water. This is important to the fishing industry, sports fishing enthusiasts, and future generations. Wildlife habitats. Our rivers and ocean waters teems with life that depends on shoreline, beaches, and marshes. These are critical habitats for hundreds of species of fishes and other aquatic life. Then you talk about the recreation and quality of life. Water is a great playground for us all. And the recreational value of our water are reasons many people choose to live where they live. Visitors are drawn to water activities such as swimming, fishing, boating, and picnicking. Health concerns. If it is not properly clean, water can carry diseases. Since we live, walk, and play so close to water, harmful bacteria also to be removed to make water safe. Need to be removed to make water safe. I'm sorry. So what are those harmful bacteria found in the wastewater? Like E. coli. E. coli is a gram-negative facultative anaerobic rod-shaped coliform bacterium of the genus Eukarya that is commonly found in the lower intestine of warm-blooded organisms. And other bacteria like Salmonella is a genus of rod-shaped gram-negative bacteria of a family, Enterobacteriaceae. These two known species of Salmonella are typical species and further divided into 6 subspecies that include over 2,600 stereotypes. And these bacteria are typically cause gastrointestinal infection. So harmful bacteria continue. So harmful bacteria found in water also can be Pseudomonas. It's commonly encapsulated gram-positive anaerobic facultatively anaerobic rod-shaped bacterium that can cause diseases in plants and animals, including humans too. So forth and so on. So we move into more, harmful bacteria found in wastewater, like coliform bacteria, fecal coliform bacteria, and Escherichia gram-negative bacteria that causes foaming, which leads to facultative anaerobic, and it is also closely linked with our food poisoning. Although we have harmful bacteria that are found in water, we also have the common microorganisms that are used in wastewater treatment to help treat the waste. So that is where we have aerobic bacteria. Those bacteria are used in the wastewater treatment plant, in which it is known as aerated environment. This bacterium uses the free oxygen within the water to degrade the pollutants in the wastewater and then convert it into energy that it can use to grow and produce. For this type of bacteria to be used correctly, it must have oxygen added mechanically. This will ensure the bacteria are able to do their job correctly and continue to grow and produce on its food source. Now, introduction, let me introduce you to Tacoma Central Treatment Plant flow. So in Tacoma Treatment Plant, the city of Tacoma treats more than 220,000 people their wastewater, approximately 700 miles of sewer pipes, ranging in size from 4 to 72 inches in diameter, and 48 pump stations with capacities up to 2,000 million gallons per day. This water is being conveyed to Northeast Treatment Plant and Central Treatment Plant. The Central Treatment is designed to provide primary treatment and biological secondary treatment using high purity oxygen and a dual digestion system. Introductions to Central Wastewater Treatment Plants flow. The Central Treatment Plant has two influent pump stations that lift raw wastewater from the screening facility to the grit removal and peak weather facility when high flow comes in. We send some part of the water to the peak weather facility to treat it, then blend it into the effluent water, send it to the commencement bay. There are 3 variable speed pumps in the new influent pump station and 2 variable speed pumps in the old influent pump station. One of the three NIPS pumps is intended to operate as a backup pump in case of the failure of a NIPS or OIPS. So NIPS means new influent treatment plant. New influent pump station, and OIPS means old influent pump station. At influent flows up to approximately 90 milligrams per day, only the NIPS pumps are online. At flow above approximately 90 million gallons per day, one or more both of the OIPS pumps will be online concurrently with the NIPS pumps. The plant influent pumping capacity with the NIPS and the 2 OIPS pump online is approximately 163 million gallons per day. However, the rated treatment capacity of the plant is 150 million gallons per day, and the influent and the effluent pump stations are currently limited to a maximum flow of 139 million gallons per day due to commencement bay at 4 pressure limitation. Yeah, screening the wastewater. Once the wastewater gets to the treatment plant, the first step the wastewater undergoes is screening. The screening facility is designed to remove large debris like rocks, rags, plastic materials from the flow stream. Removal of these materials is important because they could damage the downstream equipment. Each of the three, two duties, one standby, mechanical bar screen has a capacity of removing 75,000 million gallons per day. One screen, the wastewater can be directed to the new influent pump station or the old influent pump station. An influent 24-hourly composite sample are taken to evaluate the raw sewage, how much BOD, biochemical oxygen, and solid coming into the plant. So from the new influent pump station, it gets pumped into the grit removal. The grit tank at the central treatment plants are aerated. Air is injected near the bottom of the grit tanks, causing a spiral flow pattern which enhances grit separation and ensure that the lighter organic material remains suspended in the wastewater. The amount of air entering the tank is a key factor in their ability to separate grit. If too much air is introduced, grit will remain in suspension and will flow to downstream treatment process. If too little air is introduced, organic materials will be removed with the grit. The system is able to perform best when the airflow rate is 200 SCFM per tank, but this value may be adjusted based on the further process optimization. And from grit tank, it flows into the primary sedimentation tanks. Primary sedimentation tank is the process by which the velocity of the sludge, by which the velocity of the sewage is introduced below the point at which it can transport the suspended matter so that much of the settled and can be removed as sludge. Basically, purpose of sedimentation is to remove the maximum amount of polluting matter in the form of readily settleable solids from the sewage as quickly as economically as possible. However, this has beneficial side effects, which include flocculation of the finely displaced solids and absorption of colloidal, pseudocolloidal matters to the solids. Equalization of the strength of the sewage prior to further treatment and the provisions of time to enable possible beneficial biological change to take place in the sewage. The detention time for this wastewater in this tank is 2 to 3 hours, and this process removes about 40 to 60% solids. Primary effluent for the 24-hourly composite sample are taken to evaluate how much settleable solid and BOD removal happen in this tank. Process control monitoring. The senior operator or the operators monitor this process and make adjustments when it's necessary. Then the supervisors assigned to it. Then there are 3 major parameters available to plant personnel to maintain good operation of activated sludge system. Those parameters are the maintenance of a choosing F2M, which we are going to talk about later, and recycle sludge flow, which we are going to discuss, in later slides. Another process adjustment and monitoring again is to maintain constant sludge blanket level throughout an adequate sludge wasting program. So mechanical equipment monitoring and adjustment reports and malfunction of any equipment. Housekeeping, essential monitor of stormwater catch basins in central treatment plants and report for the sewer water pollution prevention program. That's another program that we have in a treatment plant to make sure that we are not polluting the incoming water through our storm drains. So, so from the primary effluents, the water goes into what we have a process. Then the process we have is activated sludge, conventional activated sludge process using high purity oxygen to feed our biological tank to make keep our microorganisms alive in order for them to be able to feed in the incoming bacteria, and when they feed on them, they go through an oxidation process, which cleans up the water. And so this is where my two major work products accomplished during APA. So during my APE, I monitored the oxygenation tank condition, which is essential in the operation of the activated sludge process. Then another thing I completed was using the two basic parameters, hydraulic and organic, to make process adjustments to the oxygenation tank. And this, the following lists down here are the parameters that I use, like the detention time, surface settling rate, mixed liquor suspended solid, pounds of BOD per pound of mixed liquor to F2M ratio, pounds of BOD per 1,000 cubic feet of erection volume, sludge volume index, or the density, or people call it sludge density index, return activated sludge rates, and waste activated sludge rates. All these things I'm going to discuss, and how I was able to use these parameters to achieve my goal in order to reduce toxins in the wastewater before we send it to the commencement bay. Activities completed. So I studied the oxygenation tank, which is the biological tank system, and grab samples, analyze samples to give me the proper idea of the characteristics of the microorganisms, the adjustments we made to make sure that the tank process is correct, and to make sure that the microorganisms did what they're supposed to do, the oxygen was optimized, and everything was just correct to be able to clean toxins off from the tank. So the first thing we did was to, so the biological tank system is designed to remove a major fraction of the carbonaceous material from the wastewater. So removal of this material occurs by means of biochemical reactions. So in the course of that, so we certain organisms, so certain organisms, we removed carbonaceous materials by breaking down materials into smaller compounds, which are then either oxidized to carbon dioxide and water, or assimilated along with required nutrients into new cells. So the restructuring of the carbonaceous material into new organisms requires energy, which is supplied by the oxidation reaction. The net results of these two reactions, oxidation and assimilation, are the consumption of oxygen and carbonaceous material, the production of more organisms, like excess sludge and oxidation products, and the liberation of excess energy. So another activity that I monitored during this APA was the biomass loading. So monitor the biomass loading, and so in the pounds of influent BOD per day per pound of volatile suspended solid was monitored. And so in order for us to be able to balance the food and the biomass, So we have to return a certain amount of biomass into the tank, in order to, be able to feed the incoming waste coming into the tank. So the food to microorganisms can only be controlled by controlling the mixed liquor. So in a way to achieve this goal is to control the mixed liquor, which is the volatile suspended solid concentration that has already gone through the reaction, which is the oxygenation tank. So another thing we do is the retention time. You monitor how much retention time that particular recycled or bacteria that you have, biomass that you have been bringing in and out, how much time did you give them to feed with the food, which is the toxins that comes into the tank. So it all counts, the more you give them time to feed, the more they age and they produce new ones. So when they age, the better they age, the better the clarification of the water. So on a day-to-day basis, flow cannot be controlled. Varying as the plant influence rate flows a diurnal pattern with the multiple trends can be partially controlled by taking one train out of service or putting another idle train into service if appropriate. So another parameter that we monitored was the MLVSS level, mixed liquor volatile suspended solid level. Is most easily controlled by increasing or decreasing the recycle rate. If the F2M, food to microorganism, is too high, so we found out that it could be reduced by increasing the recycle rate ratio. This will serve to raise the mixed liquor level and hence raise the MLVSS, since the two values are related by the ratio of volatile solid to total solid, and thus increase the amount of biomass under a reaction. So that comes into the second part of my APE. So the first thing was to monitor the process, know understand what is going on into the process, and then make adjustments based on the analysis taken during the time of monitoring. So how did we make those adjustments? Some analyses were taken, some sample were taken from the tank and analysis were done to make sure that the process is properly functioning. So the analysis that we ran was dissolved oxygen of the biological tank. So dissolved oxygen, since the proper operation of an activated sludge system is highly dependent on the dissolved oxygen level of the erection basins. So this text is a continuous measure. So we measure the text all over, and it's like an inline measure to check the depletion of the oxygen in the tank. So because when waste water comes in contact with the oxygen, so the microorganisms in the waste tends to deplete the oxygen level as it goes. So we have a stage 1, stage 2, stage 3, stage 4. As it goes, they consume oxygen, and we monitor those stages as as it goes. So the test continues to measure to determine consumption of oxygen in the UNOX tank. So the UNOX tank is our biological tank. So I call it biological tank, or you call it high pure oxygen tank. So so the DO means dissolved oxygen. So the DO concentration of each of these stage and in the clarifier should be measured during the period of maximum organic load. The DO value of each of the tanks. So we found out that the DO value of each of the tank should be greater than 2 milligrams per liter to sustain the biological life in the tank. The DO reading are taken manually with a portable meter intended to the respective sample pot opening in the BOD stage. So the we take samples, we take a manual sample, the DO sample, in order to correspond it with, excuse me, in order to correspond it with the inline DO meter, I'm sorry, to make sure that the DOs are properly functioning very well. So another sample we took was the analysis we conducted was BOD, biochemical oxygen demand. So biochemical oxygen demand, the relationship between the facility influence to the oxygen activated sludge influence, which is the primary effluent, and to the effluent from the clarifier, gives a good indication of the removal efficiency of the process. This analysis is performed 4 days in a week according to the ecology permit, and the sample matrix is compositive for 24 hours. The BOD of primary effluent indicates the amount of organic food material being applied to the process. This, along with the ml/VSS concentration, is used to calculate the organic loading of the activated sludge system, F2M, to microorganisms, food to microorganisms. Suspended solid. The suspended solid test was conducted to daily, to perform, to determine MLSS and ml/VSS recycle and influent and effluent suspended solid. The suspended solid analysis is performed on 24 hours compositing sample. So this actually measured how much, solids we have, and how much that will give you an idea of a little bit. So how much pounds you're going to bring it back into the tank in order to feed incoming waste. These measures are indication of effluent quality and final clarifier. So how we know that, okay, what we return, the percentage of solid that we return back to the tank is by the performance of the final clarifier. So if the final clarifier if we started seeing like, solid floating on the final clarifier, we're like, okay, something is not right. The ml/VSS is required, also required to determine food to microorganisms. Why these measures are required for sludge retention time calculations too. So we also use it to calculate sludge retention time. Oh, so another activity that we not monitored again in the tank is the pH. So a pH of 24 hours feed composite mixed liquor and the effluent is measured daily for activated sludge system operating and wastewater with high industrial fraction. So sometimes some industries, they discharge in our system. So we have to monitor the pH of the water, starting from the effluent to primary effluent. So sorry, influent to primary effluent, and then final clarifiers, which is our effluent water going out to the commencement bay. So we monitor the pH of to kind of understand, what is going on. And a pH between 6.5 and 8.5 represent the range of operation, which is good. The plant is happy. At pH outside the range, the performance of the system may decrease with respect to BOD and suspended solid removal. So yeah, pH is very essential. So another thing that is essential for removal now is the nutrients. So we did a nutrient analysis of this characterization, oscillation characterization, to make sure that the actual parameters of what the permit allows us to release into the commencement bay is the actual what is going out there. So in order for us to know if our system, the oxygenation tank, is actually performing right, so we conducted a nutrient analysis. So nutrient analysis is analysis that is conducted in a sludge system operating on wastewater with a large industrial waste flow. may require nitrogen. So we need nitrogen removal. So, and phosphorus analysis. For activated sludge system to operate efficiently, the biochemical oxygen ratio to nitrogen ratio of the primary effluent should not exceed 20:1. So, which means the BOD to the nitrogen should be 20:1 ratio, and the BOD to phosphorus ratio should not be greater than 100:1 milligram per liter. If either of these two ratios are exceeded, the BOD, biochemical oxygen demand removal, may be poor, and either nitrogen or phosphorus will not have to be added to make the, we have to be added. So if this nutrients, what if the nutrients didn't go through nitrification process and remove some of all these nutrients, then we have to add phosphorus, or we have to add nitrogen in order to, to improve our process efficiently. Another activity that another process observation and analysis that was conducted was the sludge index. So sludge volume index. We use sludge volume index to know, how much pound, how much pound biomass that we need to return, and how much pound that we need to waste into the waste activated sludge. So the successful operation of an activated sludge system is also dependent on good solid liquid separation. The most widely used indicator of solid liquid separation performance is a graduated cylinder settling test, which you're seeing in the picture here. So for measurement of initial settling velocity, which is the ISV, and sludge volume index, SVI. So we use SVI as a matter of fact. So it's initial velocity of the sludge in the maximum rate of which the solid liquid interface subsides, usually in the first 2 to 10 minutes of the settling test, expressed in feet per hour. So the SVI is the volume of sludge in milliliter occupied by 1 gram of sludge after 30 minutes settling in a graduated cylinder test. Settling test of the mixed liquor is done twice daily for SVI measurement. Best results are usually obtained with a 2-liter graduated cylinder and a gradual stir mechanism, to get a proper mixing. It is able to maintain SVI below. So after all our analysis and everything, so we understand that it is best to maintain an SVI below 100 milligram per liter. This value will be indicative of acceptable settling characteristics and should correspond to recycled sludge concentration near the design value. All right, so we're doing all these tests, trying to get the, trying to get the results and make adjustments, use the results to the data from the result to, make adjustments on our mechanical and hydraulic flow and our activated sludge, return activated sludge. Another thing that we look into is we grabbed sample from the tank and we check mixed liquor sample and we check the characteristics of the microorganisms. What do we have in our tank? What is it that we have that is feeding, the incoming waste? So those are essential, observation you need to do all the time, because there are some organisms that you don't want to see in your tank. And then when you see them early, you kind of try to make adjustments on, try to make adjustments so that the environment will be conducive to the microorganisms that are there. So a daily microscopic examination of the recycled and mixed aqueous sludge is necessary to keep up with the changing microscopic flora. So biological wastewater treatment is a duplication of nature's self-purification process on a faster scale. Therefore, the nature and the distribution of the flora is an indication of the state of the process. So what are those? Those are like microbial population. We check every day, we check the microbial population in that tank. So we check if we're seeing like bulking, something that will create bulking in our final clarifier that will make our water that pass through our contact basin and sent to the bay. But in this case, we monitor them earlier enough and then make adjustments accordingly. Like here, looking at these bite organisms here. So this one is nematode, the one my cousin is pointing at. These are nematodes, and they are really good for digesting sludge. They're really good cleaning. They clean water very well. They feed on incoming toxins, waste, and these are flocculation. So on these little crawling ciliates, they are all little crawling ciliates, and they feed on microorganisms. And this big guy here is the Suctoria. This is my favorite microorganism here. So they're indication of old sludge, as a matter of fact. And because they are old, so it's good for them to just, they're not radical they're not young, so they're not radical. They cool down and feed on waste. And so they digest sludge very well. And once you start seeing these Narcodium organisms, which is filaments, there are some filament that helps in flocculation, which is anaerobic filaments. When you start seeing, aerobic filaments, not anaerobic. Aerobic filaments, they helped in, some of them help with flocculation, but anaerobic filaments, when you start seeing Narcodia, which they grow according to our monitoring, so we realize that they grow in a dead zone where there isn't any proper mixing, or like where they don't have much air, and they grow in a foam. So their best environment is inside the foam, even though they are the one that creates the foam. So they enjoy foam and grease. So they feed on the grease, they grow, and when they grow and take over the environment, so they subdue the aerobic organisms, and take over the biological tank. And when that happens, you need chlorine to kill them. And when you start putting chlorine into your system, it kills the good ones too. So sometimes we monitor these Narcodias to make sure that they don't overpower us, and we take care of them. How do we take care of them? By wasting them more. Sometimes we add a little bit of chlorine into our return, our return activated sludge, the activated sludge that we are returning back to the tank. We add a little bit of chlorine to break their structure, because they are joined, they are structured. That's why they don't allow water to settle very well. So we break these structures to allow water to settle, much especially when they are in a free space in the water. So afterwards, the next, after all the achievement, everything that we have done, so having achieved a very good treatment in the biological tank, it is necessary that to obtain good solids liquid separation. So we monitor the final clarifiers. These are the final clarifiers. So we monitor the final clarifier sludge compaction, and then the user signs of inadequate clarification is high effluent solid concentration, which usually result in high effluent BOD and COD as well. So yeah, those are indications too. So if inadequate clarification is due to poor sludge characteristics, this can be determined either by settling test, which is the SVI that we did, or microorganism microscopic examination, like looking into the microscope, make sure that like we talked about, like I said before, make sure you don't have all those anaerobic filaments, narcodias, making sure that they're not in there to take over your system. So what we did was to earlier monitor it, make sure that those dead zones will get mechanically to feed those zones to sustain our aerobic organisms. So when we see, when we grab samples in microscopic exam, do our microscopic exam, and then the next thing is some process modification will be required to correct situation, if there is any situation at all. So what we did, but in this case, we didn't have, during this time of process monitoring and analysis conducted, so we were able to do some of the adjustments that we're supposed to do earlier before, we violate our permits. So so sometimes poor clarification can also caused by the inadequate operation of the clarifiers as well. So meaning maybe the steering wheels are not pushing very well, or something is or the clarification process, like the steering wheel may be too high in speed, or the draft tools are not picking up the sludge. So there is a lot of sludge retention time here before you know it, they'll start gassing up. So yeah, we also monitor that the final clarifier and make sure that it's functioning well. So after the final clarifier, after the water separates from the solid and we get a clear supernet water, so the cleared water goes through the chlorine contact tank. So so the water that goes through the contact tank get treated and by the use of chlorine. So we use chlorine to disinfect the water. So the chlorination process in wastewater treatment is one of the most common ways to disinfect wastewater and eliminate pathogens such as E. coli. When added to wastewater, chlorine destroys a target organism by oxidizing its cellular material. So how does so the chlorine reacts with pathogens to satisfy the chlorine demand. The chlorine remaining after the demand is the chlorine residue. The effective destruction of this pathogen by chlorination is dependent on a number of factors, including water temperature, pH, chlorine contact time, turbidity, and concentration of chlorine available after treatments. Results of the process analysis. These are the results of the process analysis conducted during my APE. So did the pH of the water, DO of the water, BOD, influent BOD, effluent BOD, primary effluent BOD, effluent BOD removal. So talk about the TSS, the MLSS, and the removal, percentage of removal. Some facts. Sorry, something is not right. So, wastewater, right? The result is recorded in the lab sheet for the lab senior to review and submit it for signatory to the plant manager, who submit the permit results to discharge monitoring report, DMR, to the Department of Ecology. When there is a violation of any of the permits requirements, the plant manager sends a letter to the Department of Ecology, Environmental Protection Agency, and National Pollutant Discharge Elimination System, NPDES, given the reasons why the plant did not meet up with the permit requirement for the week, monthly, and weekly, monthly, quarterly, and annually reports. Depends on the permits. So the city of Tacoma work with these stakeholders, National Pollutant Discharge Elimination System, waste discharge permits, and in compliance with provisions of State of Washington Water Pollution Control Law, Chapter 90.48, Revised Code of Washington, the Federal Water Pollution Control Act, the Clean Water Act, Title 33 United States Code, Section 1251. So the competencies, CEPH competencies that are associated in the wastewater so if you apply epidemiological methods to settings and situation in public health practice. One of the tests conducted in the central treatment plant is COVID-19 analysis. This test was conducted to determine the strength, the virus in the wastewater. It is often not feasible to conduct individual clinical tests on an entire population due to capacity limitation and individual testing hesitancy. So approximately 40% of people with COVID-19, both symptomatic and symptomatic cases, shared virus RNA in their stool. With the increase in at-home testing and decreased making requirements, wastewater data has potential to provide better insight into community spread of COVID-19 when paired with case data. Therefore, wastewater results can complement other surveillance sources, such as clinical testing and hospitalization data. Wastewater can also be used as a leading indicator that reveal increase in community infection rate in the wastewater 3 to 5 days before clinical testing, depending on the COVID-19 variant. Another competency is the interpretation of results. So we have Campylobacters that are commonly found in animal physics. Is one of the most common cause of gastroenteritis. So government figures indicate that it is responsible for more than 280,000 cases of food poisoning each year and 100 deaths. Most of these will be caused by poor food hygiene in the home or restaurant. However, this bacteria is also found in sewage. So coming into contact with raw sewage from a sewage spill could result in the potential deadly infection, which is why a spill kit policies are necessary and why the EPA has spill discharge clean-up procedure. So another competency is assess population needs and assets and capacity that affect communities' health. So one thing that wastewater If wastewater is not treated, it's, I don't know, the environment is going to affect the environment so bad. So like fishery. So clean water is critical to plants and animals that lives in water. This is important to the fishing industry, sports fishing enthusiasts, and the future generation. Wildlife habitats. Our rivers and ocean waters teams up with the life that depends on the ocean line. Beaches. They are critical habitat for hundreds of species of fishes and other aquatic life. Recreation and quality of life. Water is a great playground for us, and a recreational value of water are reason many people choose to live where they do. Visitors are drawn to water activities such as swimming, fishing, boating, and picnicking. Health concern. If it is not properly clean, if water is not properly clean, water can carry diseases. Since we live and work and play close to water, harmful bacteria have to be removed to make water safe. Then we'll discuss in relation with policy making, including the role of ethics and evidence. The city of Tacoma worked with Department of Ecology, State of Washington, to ensure that guidelines of permits are in compliance with the state. National Pollutant Discharge Elimination System, waste discharge permit, and in compliance with the provisions of the state of Washington. The Federal Water Pollution Control Act, and all this analysis performed for the permits compliance are recorded in the lab sheet for the lab senior to review and submit it for the plant manager signatory. Afterwards, the manager submits the permit results to discharge monitoring report to the Department of Ecology monitoring platform. When there is a violation of any of the permit requirements, the plant manager sends a letter to Department of Ecology, Environmental Protection Agency, and National Pollutant Discharge Elimination System, giving the reason why the plant did not meet up with the permits requirement for the week or monthly, quarterly, annually test. So apply leadership or management principle to address a relevant issue. So environmental services protects and restore natural resources, keeping our city clean, safe, and livable through garbage and recycle pickup, wastewater treatment, household hazardous waste disposal, protection from stormwater pollution, and much more. We believe everything we do support healthy neighborhood and a thriving Puget Sound. Living a better Tacoma for all. We work within our departments and our community to ensure that everyone play a part in keeping our community healthy. Millions of dollars are invested annually in community learning around water, cleanup, and pollution prevention. Another environmental service department operates and maintains 2 wastewater treatment plants, 45 pumping stations, and more than 700 miles of sewer pipes. The treatment plants clean about 10 million gallons of wastewater each year. 10 billion, I'm sorry. Wow, that's a lot. Ensuring that only clean water is released into commencement bay. The utility works with stormwater management and property owners to reduce sewer backups and flooding. Biosolid from the treatment process are transformed into Tagro premium soil product. Yeah, go Tagro. In conclusion, so a wastewater treatment plant is an asset to the environment and local community by remediating wastewater into usable water, thereby assessing the population needs, assets, and capacity that affect communities' health. Wastewater operators, maintenance crew, ENI, electrical and instrumentation crew, transmission crew, and source control crew work together to make sure that the wastewater treatment plant function properly in collaboration with the Washington State Department of Ecology, NPDES, and EPA. Most of the lab analysis conducted was to determine the condition of the plant and the direction in which the plant process is heading. Once an analysis result has been established, an adjustment of the mechanicals, hydraulic flow, and chemical adjustment will be made to correct the problem. If the adjustment affects the process to the extent of violation, a written report will be sent to the concerned stakeholders stating the reasons for the month violation, and an advice will be issued by the stakeholders to monitor and improve a better operational strategy to avoid subsequent violation. In the months September through November, there weren't any violation to any of the permits. The process was monitored and adjusted based on the lab analysis conducted during those periods, and equipments were rotated to improve the process. Reflection. So I really enjoyed this whole process. It's a little bit, it has a lot of details, which, my report says it all. But I really, first of all, as a matter of fact, so the most obvious thing that I discovered was the advantage of working in the wastewater treatment plant to help keep the environment healthy. I learned that good teamwork is the key to success in wastewater treatment plants, which time and resources are limited. So as everyone had their own point of view, many different ideas could be produced, and I found the energy of group participation made me feel more energetic about my contributions. Second, so I discovered that even the simplest things on each could be turned into something amazing if you put enough creativity and effort into working on them. With the use of microorganisms to treat wastewater, we eliminate pollution in our communities, water sources. This art is a perfect remediation process instead of using chemicals. We use simple monitoring methods such as grabbing samples, viewing it in the microscope to determine the population of the microorganisms and to detect if some of the organisms are causing the system to sour. That's amazing. I love those microorganisms. I learned that every system has its weaknesses and strengths, and working with a group can help discover what they are. So we challenge each other's preconceptions about what would and would not work. So we could also see the reality of the way microorganisms returning sludge to the biological tank, tank, and balancing the food to microorganisms and oxygen supply to the system affected its performance, whether negatively or positively, but always positive. So yes, this brings my APE to conclusion, and I was really happy that I was given this opportunity to be part of the process monitoring and process adjustments. And I was able to learn cool stuff, like cool things that I don't know that is even possible to do. So yeah. So, but I'm sorry, my accent couldn't allow me to, pronounce some words. Probably I try to speak very slow, but yeah. So bear with me in that aspect. And I hope you enjoy this presentation, and I hope this presentation help you with your own learning. So yeah, have a wonderful life. Thank you all.